Hey everyone, welcome back to the channel. It's been a long time since my last video on Ansys Fluent. So today we are going to learn how to simulate internal flow through pipe with Ansys Fluent 15.0. So without further ado, let's get on with it. The problem statement for today's simulation is given here. So it is an internal flow through pipe of 50 meter in length and 0.8 meter in internal diameter. The viscosity of the fluid, it is given. Density of the same means glycerin is flowing through the pipe, that is given. Dynamic viscosity is given. Okay, this is velocity 0.3 meter per second, and these all properties are assumed to be constant throughout the flow, means they are not varying with the temperature. And at the end we have to obtain velocity profile in developed region and static pressure variation with respect to axial direction. So let's start with opening Ansys Fluent. So those of you who don't know a single thing about Ansys, you have to search for workbench here and you have to double click it. Don't look at my desktop. I know it's messy. I wish it could be Ronaldo, but it's messy. So now you have to click on Fluid Flow Fluent. You can give a name here like flow through pipe, and just double click on geometry. Click on Z axis here, click on XY plane, then start sketching. I will draw one rectangle here. I know it's a pipe, but I will tell you at the end why I have drawn a rectangle here. We will give dimension to it. So go to dimension, in that horizontal dimension, then take vertical dimension, click on these two sides and drop it over here. Okay, now you have to give horizontal dimension here. In our case it is a pipe of 50 meter in length, so 50 meter over here, h1, and the diameter it is given as 0.8 meter, but we will take radius here which will be 0.4 meter. I will tell you why we have taken this rectangular box and radius over here. So let's go to modeling. Then from concept you have to create a surface from this sketch. So go to XY plane, select sketch 1. So the whole sketch will be selected, and click on apply and click on generate. So now we have created this surface, this rectangular surface. Now just imagine, just imagine that this surface is rotating about this axis, then that will create a pipe itself, and that will be our computational domain, which is the internal part of the pipe. And so Ansys Fluent provides a specific feature in which you have to analyze this rectangular portion only, and by just clicking on the axisymmetric model you can analyze the whole flow through circular pipe. So for now our computational domain will be this rectangular portion only. Now we have created the geometry. We will go for mesh, just close it. So if you don't see a right click here, just right click on geometry and click on update. So now you will see the right click over here, then go to mesh. Okay, so now you will see a thing like this. Click on Z axis once again and go to mesh, right click on the mesh and insert sizing. Now for sizing you have to select the edge. Let's select this edge and with control select this edge also and apply. So here you will see two edges which we have selected. Okay, now you can give sizing with element size, but we will take number of divisions and we will divide that edge into say 25 number of parts. And here now I will show you the use of bias factor. So I will select bias, type of bias. Okay, select this one. And you have to give bias factor. Suppose I am giving bias factor of 10. So now as you can see, the mesh is fine near the axis of the tube, axis of the pipe, but coarse towards the wall of the tube, wall of the pipe. But we need fine mesh for the wall of the pipe and coarse mesh towards the axis of the pipe. So we will reverse this bias, or you can select the other one. Say you have selected this one, then it has reversed. But now if you see on the other side also got reversed, and here once again it is fine near the axis. So for that you can go to reverse bias and select that edge and apply. So now it has reversed, and now as you can see mesh is fine near the wall of the cylinder, near the wall of the tube. Now we will divide these two edges, this axis as well as this wall of the tube, into number of parts. So once again we will take we will right click on mesh, then insert, then sizing, and we will select both the edges. Okay, and apply, and we will double click on this, so it will number of divisions will come, and number of divisions we will take say 100. Okay, 100 is not enough, we will take 200. Okay, and we will give behavior hard. This you have to do to make sure that a structured mesh is being generated. If you give soft here, you might find the mesh which will be generated, you might find that unstructured. So now you have to insert map face meshing, and you have to select the face and apply, and then click on update. then go to mesh. As you can see, a structured mesh is being generated, and the mesh is fine near the wall and coarse near the axis. Actually, we need fine mesh near the wall because the interaction between the fluid and the wall will take place near to wall. So the properties might vary abruptly near the wall, and that we have to take into account. Now mesh has generated. Let me take number of divisions 300 here, and once again update. Okay, it has generated. Now we have to give name to all four sides of this rectangular computational domain. So I will select edge icon from here, and I will select the edge, right click on that edge and go to create name selection. I will name it as suppose inlet. Okay, then go to outlet part, select the edge, name it as outlet. Okay, then once again select this edge, right click on that, create name selection, say wall. Once again select this edge, create name selection, axis. Okay, here capital small doesn't matter, you can give it a small you can keep the name as axis and with small a, it doesn't matter. Okay, mesh part is now done, so I will close it. As you can see here, the right click hasn't shown, so I will just right click on the mesh and I will update it. Okay, now right click has came, so I will go to setup. Here serial and parallel processing, two options are there, but if your system is not connected with server, then you have to go for serial processing, and if you want you can take a double precision option here. Okay, I will take it. Let's start with the general information. Click on report quality, and you can see the maximum aspect ratio and orthogonal quality and everything. And okay, click on check. Okay, then display, it doesn't matter. Now these things you don't have to change it, you just have to change this axisymmetric model. Here instead of planar you have to take axisymmetric model, then go to model. Here we are not talking about temperatures, so we will not turn on the energy equation. Okay, so energy equation we will keep it off. Then viscous flow with laminar model, we will take it, and other models they are not important. We will go to material, then okay, here already air is taken by Ansys Fluent itself, so we will just change the properties of this, and we will name it as okay, glycerin. And we will take a density of 1252 with dynamic viscosity of 0.3073. Change, create, yes, close. Okay, now glycerin has came here. Okay, cell zone condition. Here you have to keep fluid because our whole computational domain is made of fluid. Now we will go to boundary condition. Axis, edit. It will automatically show as axis because you have given the name axis. The Ansys itself will automatically take it as a axis of the axisymmetric model. Okay, then go to inlet, edit. Then here some things are there. In that you have to select the magnitude normal to the boundary, and here also you have to give absolute value, and you have to specify the velocity at the inlet, which is 0.3 meter per second. Okay, and gauge pressure. So initial gauge pressure is 0 and means it is absolute atmospheric pressure, so gauge pressure would become 0. So we don't have to change anything. Now for thermal, we are not talking about temperature, so and we haven't turned on the energy equation, so it will not come. We are interested in momentum only, and we will press OK. Then go to interior surface body, edit. Okay, go to outlet, edit. Now at the outlet we don't know about the velocity because there will be some losses along with the flow, so we will give the pressure boundary condition, and we will keep 0 gauge pressure at the outlet, so to avoid any backflow into the tube, and we will press OK. Then we will go to wall, edit. So for wall we will give no slip boundary condition over here and stationary wall, and press OK. So no need to change anything in the wall portion. Then we will go to solution method, and as of now we will keep this whole thing as it is, and we will go to solution control. We will keep this as it is, and we will go to monitors. No need to change anything here. Solution initialization, then in that we will initialize it with hybrid initialization, and calculation activities. So we don't have to change any iteration. We will not do anything over here. We will go to run calculation, and we will give number of iterations. Number of iterations you can give like 10,000, 1 lakh. Okay, I will give 10,000 only. And reporting interval, you can change the reporting interval, like after 2 interval you want velocity and every value, or after 5 interval you want those values, and we will go for calculate. Okay, so the solution is now converge. Now let's go to graphics and animation, and go to contours, then setup, and we'll select velocity magnitude, and we will display it. If you don't see this filled type of contours, then you have to click on this filled option here. You might see like this, so just click on this field. You can increase the number of levels of contours, and just click on display. So as you can see, the velocity is 0 near the wall, and it is gradually increasing towards the axis of the tube, axis of the pipe, and we are asked to obtain velocity profile in developed region. So First of all, so as you can see, near entry region the velocity profile is changing, but after some length it is remaining constant, as you can see here. So that region where velocity profile doesn't change, that is called fully developed region, and in that we have to obtain a velocity profile. So what I will do is I will go to plot here, then XY plot setup. Okay, velocity only I will select, then curve length I will select. I will go to line. I will create one line in fully developed region, vertical line, and in that line we will extract the values of velocity. So the x coordinate, we have to give the coordinates of end points of that line. Suppose this is the line, then you have to give x and y coordinate of this point and x and y coordinate of this point. So x coordinate I will give 35 meter. Okay, it is already 35 meter, and the x coordinate of the upper point will be same 35 meter. Then y coordinate will be 0 for this point and 0.4 for this point. And we will create that line 5. Then I will select line 5, I will plot it. So as you can see, the velocity at 0 is highest, is maximum. 0 means at axis, and at wall it is minimum, 0, almost 0. So you will see a plot like this. Now you have to extract the values of each and every point into Excel file. So click on write to file and write. I will select it. Suppose I am saving it here, stating velocity values, and press OK. Then open Excel. Go to file, open. And here select all files, these velocity values, open it, click on yes. Okay, next, okay, finish. So now as you can see here, it is the distance up to 0.4 radius. Okay, 0.4 radius, and here the velocity is according to that. So at a 0.4 radius, 0.4 radius means wall. At wall velocity is 0. Now it is simple to plot these things. You just go to insert, right click on that, select data, here go for velocity, select x-axis value. So on x-axis we want velocity. I will select these values, and on y-axis we want distance from axis. So I will select this value and press OK. velocity profile, press OK. Okay, so this is the velocity profile. Now the second part of the problem is to extract static pressure variation with respect to axial direction. With respect to axial direction means you have to create a line along with the axis. So same way we will go to XY plot, then we will select pressure here, static pressure, and we will create a new surface, new line. The x coordinate of one end point of the line will be 0, and for another end point it will also be 0. Okay, not 0, it will be 50, the length of the pipe, which is 50 meter, and y coordinate of both the point will be 0 and 0. Means you have created this line along the axis, line along this axis here. So the y coordinate of this both point at the end, at inlet and outlet, will be 0 0, and x coordinate will be here, at inlet it will be 0, at outlet it will be 50, and we will create it. Then we are plotting for line 6. Okay, you have to unclick this right and plot. Okay, here you have to take 1 in x and 0 on y and plot. So as you can see, the static pressure at the inlet is 300 Pascal, and at the outlet it is 0. It is a gauge pressure, so it will be 0. So at inlet we didn't know about the pressure, we knew the velocity, which was 0.3 meter per second. At outlet we didn't know about velocity, we know the gauge pressure, that was 0. So this is just a way to verify your solution. So now I will write this file also. And same way I will open Excel. Go to File, open Computer, Desktop. Here it is, Bluetooth pipe. Here you have to select all files and select pressure variation, open. Yes, next, 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 finish. So you will see this kind of data. In that you can see at 50 meter length, the pressure, the gauge pressure, it is almost nearly 0, and at the inlet pressure is 294 Pascal. Gauge pressure is 294 Pascal, and you can now add a chart showing the variation of pressure along axis. Here go to select data, go to edit, pressure variation. Okay, to be specific, gauge pressure variation, and we'll select x-axis value. On x-axis we want distance from the inlet, on y-axis we want pressure. Okay. Here you can edit chart properties. Here you can take different kinds of charts. And just right click on that, format data series, and go to line, automatic line, go to marker option, none, line, automatic black. This way you can create a plot of pressure variation. So that's it for now. If you like this video and want to learn more about Ansys, subscribe this channel and stay tuned. Catch you later.